1.6, factoring. So this is a skill that's going to come back a lot. Factoring is the opposite of multiplying polynomials. So instead of distributing all of the terms of the polynomial and rewriting a product as an addition, so we're going to now reverse that. So we'll start with the polynomial expression and we're going to write it as a product. And the first step is always to look for common terms. So if I look at 8x cubed y plus 4x squared y minus 6x squared, I notice that the 8, the 4, and the 6, they all have a 2 in common. So I can take the 2 and write that over here. Let's see, what else do we have? We have an x cubed, an x squared, and an x squared here. So that means that they all share at least an x squared. And then we have a y, and we do not have a y there. So the y is not common to all three terms. So 2x squared is what you have in common. Okay, so what do you have left then? Well, 8 divided by 2 is 4. If we have an x cubed and I have an x squared that I took out, then that should leave an x over here. And the y did not end up as part of the common term. So again, this is our common term, right? So the y did not end up as the common term, so I'm going to need a y again. And then we're going to do the same thing, so plus. So 4 divided by 2 is 2. The x squared is shared, so all of x squared is out, but the y I still need. And then finally, 6 divided by 2 is 3. And notice that I just copy these symbols here. So the pluses and the minuses I just copy. And if the x squared came out, then that's it. Now if you wanted to check, you could reverse this process and, multiply it out to see if what you wrote indeed is what you have over here. So if you do 2x squared times 4xy, 2 times 4 is 8, x squared plus another x, or times another x is x cubed, and then y. And so you could continue to do this. So what will we get? 4x squared y minus 6x squared. And you see that matches. Now usually I don't do that very often. I just wanted you to see it for this one. Okay, so that's one way to do it. If you struggle with the numbers, so I used slightly different numbers here, then you can break down the numbers and into its factors and find the greatest common factor. Okay, that is possible. So what do I mean with that? Well, for example, this. So 12 is 2 times 2 is 4 times 3. 6 is 2 times 3. And 36 is, let's see, 2 times 18, and 18 is 2 times 9, and that's 3 times 3. So you can break this stuff down, and then you can see that what you have in common is they all share a 2 and a 3. Right? They all share a 2 and a 3, and then immediately you're left with the other parts. Okay, now on this one you probably didn't need that. So I'm going to cancel all that out. Just going to write this the way that I would write this if I was doing the problem step by step. Okay, so what do 12, 6, and 36 have in common? Well, they all have a 6. You have 7 m's here, 4 m's there, and 4 m's there. So they all have at least an m to the 4th. An n squared, an n squared, and an n cubed. So they all have at least an n squared and a p, well, p to the 1st. So the most you'll have is a p in common. So they all do have p. So you do need to check that, obviously. And then we go 12 divided by 6 is 2. There were 7 m's, 4 out, so then I should still have an m cubed here. An n squared is out, and the p is all the way out. So then we're done. Then you copy. Plus 6 divided by 6 is 1. And I'm going to write that, especially in this case it's important, because if you took m4 out, and you took n squared out, and you took p out, then you do not have any variables left. But that does leave this here. So this is sort of a placeholder. You need it, okay? And if you don't include it, need it. If you don't include it, you would have a wrong answer. And then 36 divided by 6 is 6. m4, good, n3, I only took 2 out, so I need 1 more, and p cubed versus p, so I need another p squared. So there you go. Those are factored expressions of the polynomial expression that we started with. Okay, here's a little trick. I think the book calls this the big switch. If you look at a minus 2 and then 2 minus a, then hopefully you notice that they are very similar. And what you can do here is you can rewrite 2 minus a as a negative 1 times, and that allows you to change this 2 into a negative 2, and then that negative a becomes a plus a, and that actually allows you to write it this way, and that's actually a better way. Instead of writing a negative 2 plus a, we could just write that as a minus 2. And then you see that you have that term here, and now I also have it here. So if you rewrite that last part, then you would get 5 times a minus 2 minus b, so it was a negative b, but we're going to rewrite 2 minus a. So I'm going to rewrite 2 minus a as a negative 1 times a minus 2. Well, a negative times a negative is a positive, so I'm just going to make this a plus, and then I'm going to write a minus 2. Okay, so that's the big switch. So you take out a negative, and that allows you to make this positive 2 and that negative a the opposite. So positive a and a negative 2. And then this one has one more part to it. Otherwise, it still wouldn't be considered really factoring because I still just have an addition here. But a minus 2 is common in both of these terms. So if you take a minus 2 out, so a minus 2 divided by a minus 2 is 1. So that leaves you 1, and a minus 2 divided by a minus 2 is 1. Then you're left with 5 times 1 is 5, and 1 times b is b. And this is factored now, because now I have one expression times another expression, and that's what we're looking for. All right, and then the first pattern. So there are a couple patterns you need to be very familiar with, and the first one of that is the difference of squares. Okay, you should know it well. It's going to come back a lot. And what that means is that ax minus b times ax plus b can be expanded to a squared, x squared minus b squared. Well, that might be a little weird. So what do I mean with that? Well, let's look at this. If you do x minus 5 times x plus 5, and if we multiply that out, I would get x times x is x squared plus, I'm sorry, I'm ahead of myself. So x times x is x squared, and then x times 5, so that would give you plus 5x, and then a negative 5 times x, so that's a negative 5x, and you can see the cancellation there, and a negative 5 times 5 is a negative 25. And so when you cancel those, you end up with x squared minus 25. And that always happens. If this is x minus 5, and that's x plus 5, you could just square x, get x squared, and square 5, and get 5 squared, and subtract them. And that's what they're saying here. Square your first term, square your second term, and include a negative between them. Well, that means you can go backwards as well. So x squared minus 16, okay, that is factorable. Well, that's an x that's being squared, and that's a 4 that's being squared, right? So you can see we have the difference of squares, so that factors into x minus 4 times x plus 4. Sort of the same thing over here. We have y squared, and 144 is 12 squared. So this is factorable. You could write that as y minus 12 times y plus 12. Okay, so those are two fairly straightforward versions. Now let's look at something a little more complicated. And this is why I still wrote it x squared minus 4 squared. If I look at 9h squared, 9 is 3, and h squared would be h squared. So 3 squared is 9h squared. So that term matches. So can I write this as a product? Well, 16, the square root of 16 is 4. So now I have the sum of two squares. That means that it is factorable. This would be 3h. That 3 looks not very good. So this is 3h minus 4b times 3h plus 4b. Right, last one. M squared minus 121 is common to both of these expressions. So I can take out m squared minus 121. That leaves, so that's gone, that leaves 2x minus, so that's gone, 8. All right? All right, let's see what else do I have. Well, m squared minus 121 is a pattern. That is m minus 11 times m plus 11. Okay, and then 2x minus 8. Okay, some people might want to leave this, and I would probably give you full credit. But 2 is common to both x and 8, right? So I can take a 2 out, and I'm just going to copy all the other stuff. And in case you're wondering, well, how can you bring the 2 out way out there? Keep in mind that when you multiply, when I do 3 times 5, that would be the same as 5 times 3. So I can write multiplications in any order. And if I took a 2 out, then I'm just left with x, and 8 divided by 2 is 4. And then that would be the factored expression of what we started out with over here. So this is equivalent to that. They're equal to each other, except this is completely factored. It has only products, and this is, a subtraction. All right? Thanks.